Okay, so on Monday we looked at a few examples of Gaussian method. Now we're going to look at a few examples of Cramer's rule. So this is still topic 13. This is just going to be part 2. So before we can learn about Cramer's rule, we have to learn about determinants. So a determinant is a square array of numbers enclosed between vertical lines. This is different from a matrix since this yields a numerical value while a matrix does not. So the determinant formula is these vertical lines and then the A, B, C, D. Remember, we can find this A, B, C, D from our system of equations, but in these cases, we're going to give you the numbers already in the determinant, and we're just going to practice solving them. So how you solve a determinant is you always multiply A times D first. So this is your first step, A times D. So whatever is in that diagonal. And then there's always going to be a subtraction sign here. Always have that subtraction sign. And then you're multiplying B times C, so the other diagonal. And these are always going to be numbers. So you're going to multiply these numbers together, subtract them, and that number is the determinant. For Cramer's rule, we need to use determinants in order to solve system of equations. Okay. So this one's not as difficult as Gaussian method. Okay, so let's look at the first 4 examples in determinants. So this first example here, remember our formula is always multiplying this diagonal first. So this is going to be -5 times 2. We always subtract, and then we multiply the other diagonal. So 4 times 3. Once we multiply the diagonals, now we're just simplifying this expression. So we have -5 times 2, which is -10, minus 4 times 3, which is 12. So -10 minus 12 is -22. That's the answer to the determinant. Okay. Remember, we're going to be using determinants in order to solve the system of equations using Cramer's rule. Okay, let's go ahead and look at 8. Same thing, we do this diagonal, then we do this diagonal. So -9 times -10 minus, because that's part of the formula, -7 times -9. So we did the diagonal I have in pink, then the diagonal I have in green. So then I simplify. -9 times -10 is 90. Bring down the minus sign. -7 times -9 is positive 63. So then I do 90 minus 63, which gives me 27. So that's the answer to that determinant.
In no way does that minus become a plus.
Unless our, say this number 63 was negative, then we'd have minus a negative. Okay. Then that would be plus.
Okay.
But yeah, in general, with the formula, it's always negative. Okay. Let's look at number 9. Go ahead and try this one on your own. So the most important thing here is to remember you do the correct diagonal first. You mess up on the diagonals, your answer is going to be wrong. Okay, so you should have did this diagonal first. So -1 times 0 minus the other diagonal, 8 times 5. So you should have got 0 minus 40, which is -40. -40. Okay, go ahead and try number 10. This is the last one we're going to do. Again, just make sure you're doing the correct diagonal first. Okay, so you should have 8 times 9 minus -10 times -6. 8 times 9, 72. Bring down that minus. -10 times -6 is 60. So we have 72 minus 60, which is 12. Okay, so now I'm going to go back up where I had that definition of Cramer's rule, and I'm going to write the formula for Cramer's rule. Okay, so remember when we have systems of equations, we have the standard form of an equation ax plus by equals c. But we don't just have one of them, we have two equations. So I'm going to go ahead and label this one dx plus fy equals g. This is still standard form of quadratic equations, or sorry, linear equations, but this is just representing equation 1 and this is representing equation 2. Okay. I just changed the variables so it doesn't get confusing when we're writing out the formula. So in order to find the x and y value, the x value is going to be the derivative of x, the determinant of x over the determinant of the function. And y, for x,
Yes.
x is going to be the determinant of x. So the determinant is, remember these things we just did, of x over the determinant of the function. And I'm going to write out, this has a lot of information on the formulas. So this is not just the formula itself. And then y is going to be the determinant of y over the determinant of the function. So what I mean by that, the determinant of the function is going to look like the determinant of a, b, d, f. And where am I getting those letters from?
Oh, the numbers inside the lines?
Yes, so the coefficients in front of our variables. So look, I have a, b, that's the coefficients in front of the first equation, and then d, f, the coefficients in front of the second equation. Okay? The determinant, sorry, I keep mixing up the names. The determinant x is the same as saying CBGF. Where are we getting the CBGF? Still from our equations, CBGF. And then lastly, the determinant y, we get ACDG. So again, from our equation, ACDG. This is something important to highlight in your notes because you're going to need this formula for the exam. I'm not going to write the formulas, you're going to need them. Because remember, it's open note. Okay, so now that we have the formula, let's go ahead and look at number 15. Okay, I'm going to go ahead and rewrite that formula here so we have it. To reference. You don't need to rewrite it here if you don't want to, because it is at the top of your notes.
Oh, okay.
This is the same formula I just got done writing. I'm just rewriting it so we can use it as a reference for the first problem we're doing together.
Yeah, I just wasn't understanding where the ax plus by and the dx plus fy was coming from.
Yes,
Now
those
that
are
I see
just
the
representing,
equation,
yeah, they're
it makes sense,
representing
yeah.
our equations. Okay, so this is just our formula. So first we're going to look at our two equations and make sure that they are in standard form. Are both of them in standard form?
Yes.
Yes, so now we're going to label them. So our first equation, we're going to label A, B, and C. So that means our A is 5, our B is -2, and our C is 13. And then we're going to label the same thing with our second equation, but we're going to be using D, F, G. And again, I'm changing out the variables for the second equation so we don't get confused with the first. I wouldn't want to use A, B, C again, because then we would get confused. So for this one, D is 2, F is 1, and G is 7. So we're going to go ahead and turn this into a matrix, just like we did last time. So this is 5, -2, 13, 2, 1, 7. Again, I'm going to label everything so we can see. Once we have it in a matrix, then we're going to start using the formulas to find x and y. So first we're starting off with x. So we know x is the determinant x over the determinant of the problem. We have the formula for determinant of x. We know that the determinant of x is CBGF, and the determinant D is ABDF. We have all of our numbers labeled, so we're just going to plug them in. So for C, we have 13. B, we have -2. G, we have 7. And F, we have 1. So that's the first determinant. And then on the bottom, we have AB, so 5, -2, and DF, 2, 1. Now that we have everything plugged into our formula, we're just doing the same thing we were doing above. We're just finding the determinant of the top and then the determinant of the bottom, and then whatever we get is our answer. So first we multiply on this diagonal, then on this diagonal. Okay, so I'm going to be writing this on a new line. So on the top part, on the first diagonal, we have 13 times 1. And then it's always minus, and then 7 times -2. That's on the top. On the bottom, we have 5 times 1 minus 2 times -2. And then we simplify this. So we know that 13 times 1 is 13. 7 times -2 is -14. 5 times 1 is 5. And 2 times -2 is -4. So simplifying this, we have 13 minus -4. What's going to happen to that minus a negative? Positive. So 13 plus 14 is 27. And then on the bottom, we have 5 minus negative 4. So that's going to turn into a what? Positive. So 5 plus 4 is, and can we simplify 27 over 9? And that is 3. So that means our x value is 3. Okay. Now we're going to have to go through the same process to find y. So we know y is the determinant y over the determinant. We know that the determinant y is a, c, d, g. And the determinant of the function is 9. Where did I get that 9 from?
Actually, I don't.
Yeah, from the other problem at the top, because these determinants of the whole problem are the same. So we found the determinant of the bottom to be 9. So I don't need to solve it again. I just can write 9. So that means I'm only solving one determinant when I'm finding my other variable. Okay, so plugging in my top determinant, I have AC. So AC is 513, and DG is 27 over 9. I multiply on the correct diagonals, and I get 5 times 7 minus 2 times 13 all over 9. So simplifying this, 5 times 7 is 35. 2 times 13 is 26. So I have 35 minus 26, which is 9, over 9, which reduces to 1. So what's my answer? What's my point?
3, 1.
3, 1. So this method doesn't have any hard concepts. It's just a lot of multiplying, subtracting, adding, just a lot of little steps.
So in the question, it'll be use Cramer's rule, and then we'll have to demonstrate like this.
Yes. On the exam, you'll get a problem, let's say looking at 16. I'll give you those two equations and I say solve by Cramer's rule. Not going to give the formulas, not going to show you any steps because it is open notes, so you should be able to open to this page of your notes to get your formulas.
So, okay. So the reason why that was 9 is because underneath x, that determinant was ABDF.
Yes.
And it's the exact same thing for y. It's dy over that ABDF.
Yes.
Okay.
Yeah, so think of that determinant D. It's the determinant of the entire problem. So it's going to be the same for both x and y. Okay. Any questions on 15? Okay, let's go ahead and look at 16. I'm going to keep that formula on the screen there so we can use it again. Okay. So remember, my first step is to turn this into a matrix. But before I turn it into a matrix, I have to verify that these are both in standard form. So yes or no, are they in standard form?
Yes.
Yes. So now I can put it into my matrix. So I have 3, -2, 19, 7, 4, 1. Remember, I get all of those numbers from the coefficients in front of my variables. I draw my vertical line to represent my equal sign, and then I write what each problem was equal to, so 19 and 1. Okay. From here, you want to label everything. So the top is always going to be A, B, C, because that's our first equation, and the bottom is always going to be D, F, G, because that is our second equation. Once we have this step down, if you know the formulas, it's just plugging things in. Okay? So finding x first, we know that x is equal to determinant x over determinant. And we know that the determinant x is CB, GF, and determinant D is AB, DF. So we're just plugging in our numbers into this formula. So C is 19, B is -2, G is 1, and F is 4, so that's our top one. A is 3, B is -2, D is 7, and F is 4. That's our bottom one. So then we make sure we are multiplying on the correct diagonal first. So it's always the diagonal that you're going to draw to the right, and then the other diagonal, always separated by a minus sign. So that means we have 19 times 4 minus 1 times -2 over 3 times 4 minus 7 times -2. And that was just me writing out the step of our diagonals. So then simplifying, I have 19 times 4, which is 76. 1 times -2, which is -2. 3 times 4, which is 12. And 7 times -2, which is -14. So simplifying this, I have 76 minus -2. That turns into a positive, so I have 76 plus 2, which is 78. And on the bottom, I have 12 minus a -14, which turns into a positive. So what's 12 plus 14? 26. Can we simplify 78 over 26?
Yes.
To what number? 3. Okay, so we found our x value. Now we need to find our y value. So I'm using the formula for y. So the determinant y is going to be ACDG. And the determinant D we already solved, and what number did we get? 26. So I am just plugging in that ACDG. So A is 3, C is 19, D is 7, G is 1. Make sure I'm multiplying on the correct diagonals. And I get 3 times 1 minus 7 times 19 all over 26. So I have 3 times 1, which is 3. 7 times 19, which is 133. Which means I have 3 minus 133, which is -130 over 26. Can I reduce this?
Yes.
To what number?
5.
-5 because of that negative. Meaning my answer is what point?
3, -5.
3, -5. It's very important that you write the answer at the end. If you just solve for x and just solve for y and don't write the answer, that's going to be points off. So how is everyone feeling about Cramer's rule?
It's easy,
Yeah.
but it's just a lot of work.
It's a lot of steps, yeah. Okay, so let's look.
Somebody said, let me just make it a little harder.
Really, I think Cramer's rule is easier.
Oh, well, not harder, just more tedious.
Yeah. Okay, so before we move on to the next topic, do you want to do one more Cramer's rule or one more Gaussian method? Gaussian? Okay. So remember, it's on the same notes. So let's go ahead and look at number 3. Again, we're on the same notes, but we're gonna go over Gaussian one more time before we move on. Okay. So just like the first step of Cramer's is to make sure both equations are in standard form, we have to do the same here. So on number 3, are they in standard form? No, so we need to make them in standard form. So for the first one, what do we need to move over to the other side? The 5x, because we want our x's and our y's on the same side. So this becomes negative 5x minus 4y equals 34. But remember I said we don't really like a negative to be in the front of our equation. So what can I do to all the signs here? Good. If I multiply them all by a -1, what happens to the signs? They change. So now I have 5x plus 4y equals negative 34. Okay, that is going to be my new top equation. What do I have to do to the bottom equation to make it standard form? Good, just move those y's over. So I have 4x minus 2y equals 4. And that's all I have to do here because I have a positive x this time in the front. Okay. So once I have my two equations in standard form, what do I have to do next? Good, put it into a matrix. That's what I'm going to do. So I have 5, 4, negative 34, 4, negative 2, 4. Okay. When I have my matrix set, what's the first thing I'm looking for in my matrix? If I have any 1s or 0s, and that kind of tells me if I have a starting point. Does this have any 1s or 0s? No, so I need to create my own starting point. So this is where there's multiple ways to do this. We got to kind of think it through before we try to solve. So which one do you think would be the easiest to turn into a 1? If we don't have a starting point, we always start with 1. The -2. Why do you say that one is the easiest to turn to 1? Good. We could multiply it by 2, add it to the 4, and, well, no, because that would give us 0 if we did that. If we multiplied by a 2, we'd have -4 and +4, so that would give us a 0. Any other ideas? Using 4 to make our 1? And how would you do that? You gotta have a reason. Okay, so the -2 is correct. The -2 is correct. Look at that last row. We have a 4, a -2, and a 4. Is there something that we could divide that whole bottom row by to make that -2 a 1? A -2. So remember, this is row 1, row 2. So we can take row 2, divide it by -2, and we get a new row 2. The reason we can do that is if we divide all of these terms by -2, we're not going to end up with a fraction. We're going to end up with a whole number for each one. Okay, so that means which row is staying the same?
Row 1.
Row 1. So I write 5, 4, -34. And then I'm dividing row 2 by -2. So what's going to be my first number? -2. And then 1, because that's what I was trying to get. And then again, 4 divided by -2 is -2. Okay, so that means we have our 1. Remember, if we find a 1, our next step is to find a 0. And what are the only two numbers that we could make 0?
-2 and 4.
Negative 2 and 4 would be our only possibilities. So what do you guys think? Which one would be easier to make 0? So if we say negative 2, what are we doing? What's our formula? How could we make that 0?
It would have to be a way that we leave the 1 alone, right?
Yep, we can't change that 1.
Can we divide it by -2? No, that would
That
be
would
1.
change the 1, and that would also change the 1. What about that 4? What could we do to row 2 and then row 1 to make that 4 a 0?
Subtract 4
Subtract 4 from...
from 4, and that would also give us a 1 on row 1.
Multiply row 2 times -4.
Correct. Multiply row 2 by -4. Because then what happens to the 1 when we multiply it by -4? Turns into -4. So now we have 4 over -4. So that means we would have to add it to which row? Row 1, because that's what we're trying to change, right? We're trying to change the number in row 1 to give us a new row 1. So what we're doing is we're doing -4 times 1, which is -4. -4 plus 4 is 0. In this way, we're not messing with the 1. We're using the 1, but we're not changing that row at all. And let's start to rewrite this so you can see. So again, row 2 stays the same. We're taking -4 times row 2, which is -2. What number is that? 8. And then we're adding it to row 1, so it's 8 plus 5. 13, so that's our first one. Then we're doing -4 times row 2. That's -4. Add it to row 1, we get 0. Then we have -4 times row 2, so that's -2, and we get what? 8, and then we're adding it to row 1. What's -34 plus 8? Yep, -26. And now we have a 1 and a 0.
So what I said about subtracting 4, why wouldn't that work? Because that would also give us the 1 on the other side, wouldn't it?
So when we're manipulating an equation, we can't just simply subtract a number. Notice how in all the things we're either multiplying or dividing.
Okay.
So your first step is always going to consist of a multiplying or dividing.
That's good to know. Okay.
And then usually you're adding that to a different row. So how we did here, we multiplied by a number, added it to a different row. For this one, we divided by a number because we were trying to change that same row.
Okay.
Always multiply or divide. So we found our 1, we found our 0, so that means the next one we need to find is a, what's next?
Another 1 or 0.
Remember, there's a pattern here. We find a 1, we find a 0, so we have to find a 1. And what's the only one that can be a 1? 13. How can we turn that 13 to a 1? Yep, divide that row by 13. So we would do row 1 divided by 13 is going to give us our new row 1. So which row is staying the same? The bottom one. Good. So in the top one, we're just dividing each one by 13. So 13 divided by 13 is 1. 0 divided by 13 is
0.
And then negative 26 divided by 13.
Negative 2.
Okay. So what's our last step here? Good. We need to turn that negative 2 into a 0. What did we do in the last part where we had to turn a 4 into a 0? So look at this part. What did we do in order to turn that 4 into a 0? Because we're going to use that same method to turn that negative 2 into a 0.
Oh, we multiplied and added.
Good, we multiplied and added. So we're going to do multiply and add for this one. So which row are we going to multiply and by what? And which row are we adding it to?
Multiply row 1 by 2 and just subtract the 2 to make it the 0.
Good, yes. So row 1, we're multiplying by 2. And then we're just going to add, oops, I wrote the wrong row. Row 1, we're multiplying by 2. We're going to add that to row 2. Because then we'll have 2 and a negative 2, which is 0. And that's going to give us our new, which one? Row 2. So that means what's staying the same here?
Row 1.
Row 1. So I have 1, 0, negative 2. Okay. Now I use my formula I just created. So 2 times row 1, which is 1. So 2 times 1 is 2. Add it to row 2. We get 2 plus negative 2 is 0. Remember, 'cause that's what we were trying to find, 0. Oops. Okay, then we do 2 times row 1. So 2 times 0, which is 0, and add row 2, we get 1. Notice how these equations, these formulas we're creating, does not change our original 1 and 0s that we found earlier. Okay, and then last part here, we do 2 times row 1. So 2 times negative 2, negative 4. Add it to row 2. Negative 6. So that means our answer is what?
Negative 2 comma negative 6.
Negative 2 comma negative 6. Why is it not reversed? Why is it negative 2, negative 6, and not negative 6, negative 2?
There's 1 in the X.
Good, because this 1 right here is in the X place, and this 1 right here is in the Y place, which tells us X is equal to negative 2, Y is equal to negative 6. That's why we got negative 2, negative 6, and not the opposite. So that was our answer for 3.
So when finding zeros, you could say it's going to be like the multiplication, then add, and then when finding the 1 is just the straight across.
The divide, yep. I think the hardest part is just deciding which number you're starting with if you're not given a 1 or a 0. But typically you want to look at, you'll first look at if this whole row can simplify by dividing by a number. And if that's not the case, then you check the other row. Can this one simplify by a number? So you're trying to find which one's easiest to get 1. Always start with 1 first, unless you're given a 0, okay? Because if you're given a 0, then you know you're looking for 1 next.
We both have 1 and 0.
If you have 1 and 0, then you can choose. If you're choosing your 0 to be your first, then technically the 1 was found for you, so then you need to find another 0. It's always 1 0 or 0 1. You have to follow that pattern.